Globally, 1.6 billion people worldwide, or rather 20% of the human population, lives in inadequate housing conditions, with about 15 million forcefully evicted every year, according to UN Habitat. They have marked an alarming rise in homelessness over the recent decade. Homelessness is a global problem that affects both people in developed and developing countries regardless of economic, social, or cultural backgrounds. Some parts of Asia and South America tend to have more populations than the capacity of housing. Given the dynamics of supply chain and demand, a house can be too expensive in such countries. But with the recent technology of large-scale 3D printing, affordable housing has the possibility of becoming a reality for many people who would otherwise not be able to live in a shelter. As 3D technology proceeds to develop, we keep on seeing its exceptional advantages and how it tackles a variety of issues. One such issue is affordable housing. The way to build a 3D printed house isn't simply extraordinary, but also faster than conventional construction. The promise of a reduction in waste and time followed by handling labor shortages seems to be the answer to many of our world's housing problems. Giant 3D printers can create houses less expensive and quicker than conventional building methods. It can effectively be home to many individuals worldwide. Now, before we begin, remember to like and subscribe for more great tech content every single week. In 2015, the NASA Centennial Challenges program hosted the 3D printed habitat, known as 3DPH, competition to foster housing answers for long exploration missions in space utilizing advanced construction technology. The fundamental objective of this competition was to utilize the native materials and mission recyclables as feedstock for huge-scope, self-sufficient 3D printers to develop a territory on Moon or Mars. Phase 1 provoked groups to develop cutting-edge design ideas that exploited remarkable abilities offered by 3D printing. In Phase 2, teams 3D printed underlying segments utilizing natural materials and recyclables. Phase 3 tasked competitors to create subscale living spaces utilizing indigenous materials with or without mission-generated recyclables. The development from this test are both valid to both the satisfaction of NASA's Moon to Mars mission and the making of reasonable and sustainable housing solutions on Earth. To summarize the 4-year challenge and give an outline of the team's accomplishments, this competition provided a plethora of humanitarian and business opportunities. This improvement of 3D printed houses answers for people in need of shelter in such places such as Austin, Texas, or the United Nations Habitat headquarters in Nairobi, Kenya. Phase 3 Level 5 champ AI SpaceFactory is currently 3D printing eco-friendly houses in New York called Terra, a full-size territory plans for Mars and accessible on Earth. Constructing a 2,000 square foot house generates more than 8,000 pounds of construction waste on average, most of which ends up in a landfill. The main commitment of 3D printing offers a sustainable development in the decrease of waste. After designing a home on a computer, a 3D printer knows the exact specific measurements of materials required for the development of the house. Utilizing smashed earth, mud, clay, and other natural materials for construction practices have been around for at least 10,000 years. When a house is constructed with the old-age organic practices with modern innovation of 3D printing, then sustainable architecture reaches another level. Such effective construction strategies will diminish waste, decrease material transport costs, improve building life expectancy, and lessen the absolute working expenses. By limiting construction waste and material transport costs, 3D printers can radically lessen carbon footprints, which is amazing for the environment. Moreover, 3D printers can be created to make homes out of sustainable and renewable materials. While some of us might think affordable and simple construction techniques are outdated, many designers and architects are exploring different ways to blend them with 3D printing. The hut named Casa Covida is created using soil mixed with straw, sand, and other organic materials to 3D print, a successful experiment run by the California-based studio Emerging Objects. The house built by the studio has 3 parts: a central, a sleeping, and a bathing space. The organic structure is a prototype that accommodates 2 people and has been 3D printed in the desert of San Luis Valley, Colorado, using a 3-axis SCARA, selective compliance articulated robot arm, that extruded out of a mix of sand, silt, clay, and water. The rooftop is quite possibly the most fascinating highlight, and has been inspired by a blooming cactus as a gesture to the desert area. The cell phone-controlled SCAR automated printer utilized in this Kasakova is lightweight enough that only 2 individuals need to operate it. This might be a test model for the present, however, the objective is to cater for the vital concerns. The restriction of modern technology and materials with the potential outcomes of restoring ancient strategies and materials in an advanced setting. Humanity has been developing the utilization of mud for 10,000 years. The way mud effectively provides thermal comfort with no impact on the environment is surprisingly extremely sophisticated. We're getting back to a more elevated level of development framework by streamlining and figuring out the utilization of locally available materials. An Italian architecture firm is also approaching making houses more affordable and better for the environment by using a modest and promptly accessible structure material, local soil. Recently, near the city of Ravenna, Italy, multiple 3D printers have slowly laid down layers of earth to form a dome-shaped house called Tekla, technology and clay. Mario Cucinella, founder of this Italian architecture firm, created the project, working in collaboration with engineers at the Italian pioneer and 3D printing company called WASP. In fact, WASP's official website says, "We're dreamers, we're makers. We start from 3D printing to save the world." The aim of WASP is to build zero-mile homes using materials in the surrounding area. A similar project requires that the machine be portable and features low energy consumption, since in some areas of the planet there is no electricity at all. It must therefore be able to use renewable energies such as the sun, wind, and water. These guys really seem to care, and so far, the projects realized by them are 100% self-financed. One of WASP's newest machines is called the Crane WASP, which includes a WASP Maker Economy starter kit comprised of multiple 3D printers. First of its kind in the world, 2 printing arms were synchronized as a feature of construction. The software was optimized for complex movements, avoiding collisions and ensuring simultaneous operation. Tekla is comprised of 2 domes merging and facilitating a living open space and a room furnished with a small toilet. The dome shape of the home makes it structurally strong, and the thick walls provide insulation. A skylight at the top of the dome brings an extra light. Outside, a pond gathers waste and rainwater to be reused for the garden. Other highlights include solar and thermal panels giving clean energy to the house, possibly making it a self-sufficient home. Italian architects and WASP build the 645 square foot sustainable 3D printed house from raw earth in about 200 hours. With this brand new system and production speed, Tekla homes become a new circular model of housing, which is entirely created with reusable and recyclable materials sourced from local soil, carbon neutral, and acceptable to any climate and context. The team further plans to do performance tests and explore variations on the design, including a 2-story building. It hopes it can share the solution widely, especially in low-income countries. The design can be adapted based on the local soil and local climate. As per the United Nations report in 2017, the world current population of 7.6 billion is expected to reach up to 11.2 billion by 2100, and by 2030 alone, nearly 5 billion people will be living in cities globally. Consequently, governments need a substantial housing solution. With more and more rural areas being incorporated into cities, it is the idea of a city itself that must be challenged. Such methods built to adapt to multiple environments will be suitable for self-production. By using this new construction system, it'll limit industrial waste and offer a unique sustainable model that will boost the national and local economy, improving the well-being of communities. The Tekla team aims to significantly accelerate the construction process, as the 3D printer will produce an entire structure at once. 3D printed houses are gaining popularity in various nations that are experimenting with it. For example, developing nations like India have recently built their first 3D printed home of 600 square feet in 5 days. Whereas developed nations like China is advancing in this technology aggressively because it is better, faster, cheaper, and more durable and capable of fluid designs. 3D printed homes hold a promising roadmap for the future of cheap housing. I believe the WASP manifesto says it best. to print a healthy, beautiful, and human-scale home with a cost that tends to be null. Earth is available everywhere in the world. It is cheap and easily malleable. Combined with other zero-mile local materials, clay can create printed buildings that last in time, that adapt to the territory, and that do not leave ruins behind once no longer used. If such a solution is adopted at scale, this approach could put roofs over millions of people's heads. What do you think about these 3D printed houses? Let us know in the comments section below. If you enjoyed the video, please like and subscribe for more. Thanks for watching, and we'll see you in the next video.